So let's talk a little bit about what happened in the last lesson. We spoke about this thing called depreciation, and some of the words that came up were a little bit unfamiliar. So let's just have a quick little recap of that. When we talk about depreciation, we often talk about straight line depreciation, or we talk about reducing balance depreciation. And another way of thinking of these words is to think of this as simple depreciation and to think of this one as compound depreciation. So those words are used interchangeably, and you want to make sure that you're comfortable understanding what's going on. Now, each of those words relates to a different formula that we use to calculate depreciation. And so let's just make sure everyone has got that. So A equals P1 minus I times N is for straight line or simple depreciation. And for reducing balance depreciation, we have that formula. Now, what is a bit confusing with depreciation is that the p-value is actually normally the bigger value in this formula. And the reason it's bigger is that if your initial value is something and you're losing value, then P has to be bigger because A will be lower. It's the lower value. So say, for example, you buy a new iPhone for 15,000 Rand, and in 5 years' time, it's not going to be worth more than 15. It might be worth like 10. And so the A value, or it might be even worth like 7. The A value will be less than the P value when we're doing the depreciation calculation. The other thing that's different about depreciation is that it has these negative signs to incorporate the losing of value. But otherwise, it's not that different to interest. Okay, give me a thumbs up if that little bit of revision is clear to you. Give me a thumbs down if some of the stuff I said there, or even if you have a question, you can put your hand up just to clarify. All right. Now, in these questions, they often give you 3 of the values and you have to find a 4th value. So maybe they will give you like P and I and N and you must find A. Or they can give you A and P and I, and then you must find N. So what we want to get comfortable with is the different variations that are possible for you to kind of get comfortable with. So let's go here. It says, find the missing value if straight line method of depreciation is used. So I want you to write down the formula that is going to be relevant for that. I'll give you a second to write it down, and then I'm going to write it down too. What do you think the formula is that goes with this? So you should have written that. And what I want to start with doing is I'm going to choose some questions for you to do. So the first one you're going to do for me is A, and then you're going to do one for B, and then you're going to do C. Now, just to point out, in A, you are trying to find A, in B, you are trying to find P, and in C, you are trying to find I. So I want you to give those 3 questions a go, just to see how comfortable you are with using the formula to find different values. And then if somebody is unsure, I would encourage them to ask a question or put something in the chat that I can respond to. But otherwise, over to you guys and girls, see what you can do to make that happen. Yep, you're right. That is the correct formula, straight line depreciation.
Mr. S, I have a question in chat that says, are we going to do installments with the F and X method today?
F and X. So the F and X method, that sounds like grade 12, like annuities. So I don't think sometimes you do hire purchase in grade 10 where you talk about purchasing something with hire purchase, but F and X, that would normally be a matric thing. What some teachers do to get kind of in the mood for grade 12 is instead of using A and P, they use future value or F for A, and they use present value for P. So I don't know if the student means that, or some teachers like students to start thinking about F as the output value and P as the input. So I don't know if that answers the question of the student. Maybe they can have a look at the chat. Maybe I missed something. Hi, everyone. Okay, I didn't see that. Yeah. So yeah, in matric, sometimes we use FV and PV, but for now, I'm going to stay with A and P. Now, some of you may have teachers who do it slightly differently to this, and that really isn't a problem. As long as we're getting the same answer, it's fine. I know some teachers like to move the formulas around or the variables around and then put the numbers in at the end, which also is fine. So 7848.61 would be the answer for B. Okay, are there any questions about B? But what I see in the chat is Mesh agrees with me and Morgan agrees with me. Okay, so now we're all trying to do C. Let me choose a different color. Tia, I think you just refresh your screen maybe, or go in and come out again. I think that might help with your screen not working. I don't think you need to take, I'm doing quite a long way with working out here. But yeah, let me, if that's 7i, what am I going to get for my final I value? I'm going to take this whole big thing and divide it by 7, basically. I need to get rid of the, so I can basically go divided by 7 on this side. So what are we going to get for my I value? So actually, this is going to round up to 6.8, 6.90, because it's going to round up. So for C, we should get a depreciation rate of 6.9% per annum. It loses 6.9% of its value for every year that goes past. Okay, from what I can see, you guys are doing really well. And there's just one variation that I still want to test out, which is N. So we're actually just going to do D, and then we'll move on from this. So we're going to do D. And in question D, you have to find N, which is how long does it take to go from here to here. So try and do D for me, and then we're going to move on from simple depreciation. We're going to move to compound depreciation. Oh, I see we have lots of students in the room now. I'm impressed with my class here. You're showing good discipline. I know that it's an extra bit of effort to get you when you, so yeah, well done. So the tricky thing with D is you have to get that N by itself. But, you know, it's actually not too bad, because you just have to undo the 1. A lot of these values can actually be just kept in your calculator, but if you get the -1, you're going to get your minus 0.063N. And then the final step is going to be to get the N by itself. And to do that, what do I need to do? Let's use a different color just to make it extra clear. So I divide this side by that. And this would cancel, and I get left with just an N. Now, what is the value going to be that I get on the other side? I need my calculator for that. Okay, so I get 1.13, and so that's going to be 1.1 or 1.13 years. Now, it didn't say anything about, yeah, it will stay in years. We don't need to break it up any further. Okay, give me a thumbs up if you feel, oh, can I scroll up again? I can, or I can zoom in even better. How about that? So then you can see the whole thing. Give me a thumbs up if you feel okay with simple or straight line depreciation. And once I get a sense of how the class is doing, I'm ready to move on to the compound one. Okay, fantastic. So if you need to take a screenshot now, for some students who want to keep a bit more detail, you can do that, or you can go back to the recording as well. Okay, now things are going to change in the second bit of the thing, because we're now looking at the reducing balance method of depreciation. And with this depreciation, what sometimes happens is that it's not always depreciating on a yearly basis. So here it says compounded semi-annually, what actually means it's depreciating every 6 months. Over here, it says quarterly, which means it's 4 times a year or every 3 months. Over here, so there's different compounding periods. So that gets a little bit trickier. The other thing that is a little bit trickier is the formula looks a little bit different. So let's go a bit slower with this one. In this first situation, you are given you're given the initial value of how much something is worth, and I want you to try and figure out how much it's worth at the end if you depreciate it at 7.7% compounded semi-annually. Just give it a go by yourself first. Even if you make a mistake, I just want you to fly solo, and then I will come in and answer questions if we get confused. So give it a go, and then if there are questions, you can ask in the chat there. So one of the things I want you to notice is that the interest rate, I don't want my interest rate to be a yearly interest rate. I want it to be a semi-annual or every 6 months. Oh, did I make a mistake? Oh, you're right. I made a boo-boo. So let me change that. 0.077. Well done to everyone who spotted that in an absolute second. And so what is this going to be? So what do we have for that? Okay, well, what I'm getting is, and let's see what the people of the room are saying. Oh, we're agreeing. It's 4,803.96. So it's gone all the way from 6,080 and it's depreciated down to that amount. And the big difference was that the interest rate had to be broken into a semi-annual interest rate. And also the number of 6-month periods is 6. Now that's a bit trickier. So I think we need to practice another one straight away. And so I want you to try and do I. And in I, it has the same basic structure, except it's compounded monthly. But everything else is quite similar. So try and do I using the same basic idea that we used there. And if there are questions, I definitely encourage you to let me know in the chat. I'm keeping an eye on things, and I'm happy to have a chat, but I'm seeing good engagement in the room. And so, yeah, just keep swimming if things are going well. Yeah, what are we getting? Well, I am getting 4389.83. And so it's depreciated from 5,310 all the way down to 4,389. And if I look there, Annie agrees, Jasmine agrees, Cheval agrees. So it feels like we should just keep swimming because the class is on form. Okay. So now the question is, what other type of question could we ask? Well, instead of working out what A is, can you work out what what should I look for? P, compounded daily is not ideal for now. Let's do finding, let's do F. So I want you to find me what P is, and it's compounded annually in this case. So once a year, the depreciation happens. See if you can work out the answer for F. Let's see what people are saying for the value of P. I think the problematic bit is here. If we could just move this whole thing to the other side, but we know using the laws of algebra, we can do that. So this whole bit, if it's times on this side, it becomes a divide on that side, or you can say you divide both sides by that. And that will give me my p-value. What are we getting? We get 24536.90. And so it was worth that at the beginning, and then it lost. Yeah, so basically it was 24,536. And Sichaba agrees with me, Jasmine agrees, Suelo agrees. So I think there's a very high probability that we are in the right thing. Okay, well, what's one that we haven't done yet? So we found A, we found P. Is there any question which varies? All of these are actually only looking for A and for P. So I think we're okay with this type of question. So let's just do one more just to make sure we're good. Let's choose one that is, it's finding P, compounding daily. Let's do H. So I want to do H. Can you find what P is for question H, or letter H? Tando, am I working you hard today? I know, it's just like my expectations are rising so quickly. So, you know, I kind of like, you know, when you're a gym instructor and you're like, one more, guys, from the top. Yeah. You can do it. Okay, what do we think the answer for P is going to be? So if that's sitting on that side, then this must be let's have a look. 833 over bracket 7 over 4, and then to the power of 6. Let's see if we all agree. I'm getting Swandile. Hey, 867.55 if I round off. So that is what I will get as my initial value. I start off. Can we please do B or D? We can do that. We'll do it after the break, in Corsi. So let's not, I absolutely can do the daily one. That's not a problem. But I think what we need to do is just give me a thumbs up if you were okay with H. Give me a thumbs down if you weren't okay with H. But I do think we need a break now. We've pushed hard for a good solid half an hour now. And your brain does need a break. Even my brain needs a break. Okay, cool. Well, then I think what we need to do is we need to stand up. And yeah, even if you're not feeling particularly physical today, it's just because of how we're made that our bodies need a bit of movement to unwind. So let's just start by just loosely shake your arms, kind of get things flapping, get some blood flow, shake your legs. Okay, and then let's take those shoulders that have probably been hunching over. Let's just relax them a little bit and just roll nice and loosely. You can roll them back, and then we can roll them forward. Maybe take your neck and just put it to one side so it kind of stretches a little bit. And then to the other side, you should feel a bit of tension in the back of your neck as it stretches, kind of like a band. Okay, let's do tricep. So we'll stretch that out. Okay, and then to the other side. Okay. Oh, okay. Swing those arms up in front of you. And let's do some small circles. slope going into bigger circles. And then let's go the other direction with big circles going into small circles. Okay, then we need some heart rate raising stuff. So we're going to do air skipping, and we're just going to do 20 of them. And 3, 2, 1, let's go. 4, 6, 7, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 5 more. 1, 2, 3, 4, 5. And that is our heart rate raising activity. I do notice that air skipping is a little bit more friendlier than jumping jacks. My heart rate is not quite as pushed as it was from jumping jacks. Let's just do a bit of a math 24 question. So see if you can figure out how to make 24 using either of these two cards. Yeah, see if you can figure it out and put it in the chat if you can. Okay. Conke and Keisha and Annie. Oh, you guys, 8 plus 8 plus, oh, that was an easy one. Well done. You spotted that quickly. 24, absolutely. Now, this is a 6 on the blue card, and it's a 7, and a 5. Can we make 24 with that card there? What can we do with these? How can we get the 7 and the 5s to interact? Well, the 7 and the 7 and get a 1. We could say 6. A little bit of a tough one, eh? Who feels like they might have the answer here? Otherwise, we can always come back to it another time. 7 minus 5 is 2. 2. Oh, this is tricky. Okay, maybe later in the lesson we can come back to it, because even for me, it's not appearing to me in a vision at this point. 6 times 5 is 30. Would that work? No. 7 times 5 is 35. Would that help? So 7 times 5 is 35. And then okay, we'll come back to this one. I don't want it to become a Math 24 lesson, but that is definitely a tricky blue one. We'll come back to it at a later stage. It's good to be challenged though. Okay, we'll come back to it at the end of the lesson for a little bit of fun. Okay, so let's move. Before the break, we said, can we do the one with the days? I think that was the question. So if it's compounded daily, it would be a question like, let's do K. Now, see if you can do this question, solving for P, but realizing that you're compounding, you're depreciating on a daily basis. So 365 is going to be the value that comes into play. Yes, Tando. So in this case, I would start by going, A is, you write that out, and then you don't know what P is, but in this type of question, I would start by saying, if it's daily, this should be divided by 365. But now the interest rate is a daily, or the depreciation rate is a daily depreciation rate. Now, it doesn't help if your time is in years and your interest is in, or your depreciation is in days. So you need to, oh, Mzwandile has, so we are doing K, and we are finding the value of P, and it's a depreciation, a daily depreciation rate. So we work out the daily depreciation rate by taking the annual rate and dividing it by 365. And then we take the N, which is 3, and we times that by 365 to get the number of days. We're losing value every single day. And this 1,095. And so see if you can find me the answer for that one. What do we think P is going to be in this case?
Greetings, sir.
Hey, how's it going?
Can I ask for
How
the
can I
daily part?
Yes.
For the daily part, can't we like say, like, why didn't you say 365,25?
Ah, sneaky. Yes. Okay. So if you really want to be perfectly technically correct, the Earth goes around the sun 365 and a quarter. So I agree with you in terms of like geography, but for now, we just sort of assuming that at 365 is okay. So we don't really worry about that in this calculation. If you're working for NASA, you definitely would worry about it. But for here, it's okay. We can ignore it for now. But good question.
Thank you.
So, okay, so let's go 7460 over 1 minus 0.0499 over 365, and then close brackets to the power of 1095. And what do you all get? So what are you getting for your answer? So Annie, the way that a year comes from, I think a couple of people are asking about the 365 thing. A year is how long it takes for the Earth to go around the sun. That's where a year comes from. That's how we get the length of a year. And so in space, it actually takes 365 and a quarter. And that's why every 4 years we have something called a leap year. And otherwise, everything would go out of sync. So that's a bit of bonus geography, just because, yeah, we're always learning. So what are we getting? I just zeroed out my answer, so I have to do this again. 1 minus over 365 to the power of 1095. And we get 8664. 8664.77. Okay, awesome. I think that we are good. Thumbs up if you're okay with that one. Thumbs down if you're unsure. Just get a feel for the room. Just want to get a sense of how people are feeling. That was a tricky one with the 365. No. The key thing with compound interest or compound depreciation is if the interest rate or the depreciation rate is per day, your interest rate has to be per day, and your time period has to be per day, and you just have to adjust them, and then everything else is fine. Okay, now we're going to finish today with a mixed question. So we're going to mix in a little bit of interest and depreciation. It's almost like a remix. So let's go through this question together. It says, let me get the other thing. Kai bought a car 4 years ago. He now wants to upgrade to the latest model. Don't we all? 4 years ago, he invested 60,000 for 4 years at an interest rate of 9.6% per annum compounded monthly. Okay? So that's a whole long story that we have to make sense of. But then it says he will use the investment to pay cash for the new car and use the old car as a trade-in value. So there's quite a few things going on. Often when you want to buy a new car, you'll save up for a little bit, but then sometimes you'll also have a car that you can trade in already. And so he's going to use a bit of cash that he saved and some of the value of the car that he's got already. And how much value is sitting in the car is often called the book value. Okay. Calculate the value of his current car if he paid 160,000 Rand for it and depreciated it at 12% per annum on reducing balance. Okay, so let's start by doing the green bit. I know that's a whole long story, but really all I want to know is, it says calculate the value of his current car if he paid, so originally he paid 160,000 for it, and it's depreciating at 12% per annum, but it's on the reducing balance method. And there's no mention of days or things. So it's just going to be over one, or it's just going to interest is that. And the N is going to be what? It says here 4 years ago. So N will be 4. Yeah. Thanks, Morgan. So sometimes when the questions are very wordy, you almost have to go back and dig for the information. So tell me, how much is this car worth today that he can maybe use in his trade-in value? So I get 95951, and I'm just gonna, and then it says 0.26. Yeah. So the car is no longer worth 160,000, but you still have quite a lot of money that you can get for selling the car or trading it in. Okay, let's move on to the next part of the question. So at the beginning of this, it says, assuming inflation over 4 years is determined at 9% per annum, calculate the price of a similar new car. Now, this is where we need to start to think what's going on here. 4 years ago, this car was worth 160,000, but I want to now go into the future and work out how much that same car would cost in the future. What formula do you think I need to use for this? Because it's not going back, we're not losing value, we're saying, look, we need to afford this new car and we're trying to work out how much does it cost. Yeah, so we need to use not the depreciation, we need to use the compound interest formula. Can you work out how much an equivalent car would cost today for me? I hand it over to you guys. See if you can work it out. Now, the inflation rate was 9% per year. So it's going to be 0.09. And this is going 4 years into the future. So what are we getting? 160,000 times. Notice how I'm not dividing the 9 into smaller pieces because it's a yearly inflation rate. So the interest increase is 9% per year. So that's why we're staying in years. To the power of 4. Yo, look at that. That's how new car prices go up so quickly. 225,853.06. So a car that used to cost 160,000 4 years ago is now, that same car is going to cost 225,853.06. Keisha, what is your question? You can unmute yourself, or we can unmute Keisha now.
Hi, sir.
Hey.
Sir, I have a question. Why are we using a plus, not a minus?
Okay. It's got to do with the word. Thank you for your question, Keisha. It's got to do with this word, assuming inflation. When they use the word inflation, you may have heard people complaining recently about food prices going up. Inflation is putting food prices. So when they use the word inflation, it means that we don't use the depreciation formula. We use the compound growth formula because things are going up, not down. Does that make sense, Keisha? That the word is different, so we're using a slightly different idea. Okay. So, last part of this question. Now, 3.4, so the old car is worth that much. The new car that we want to buy is worth this much. Okay, so that's the story so far. The dealer offers Kai a 12% discount on the price of the car. I want you to work out what the price of this new car is after discount for me. So let's do that one first. So the dealer is giving Kai a 12% discount. Work out then what the new car price actually is after that discount is taken into account. No problem, Keisha. I'm glad I could help you. Thank you for your question. I think you helped a lot of students there. So the actual price is going to be, that's how much money he needs to buy his new car, because you get 27,102 as a discount, and that's how much the new car would cost. So take a moment if there are any questions about that or comments. Then it says, calculate how much cash he must find to pay for the new car after trading in the old car and withdrawing the investment. Now, we haven't actually calculated how much his investment was. So let me just go back. I know we're running out of time today. 60,000 Rand for 4 years at 9%. Okay, let me put this down. So 60,000, the interest rate is compounded monthly. So I'm at the top here. I'm actually just looking here. 9.6 monthly, and it's 4 years. So N is 4, but because it's in months, it's going to be that. So here is, I'm going to do this last bit for you because we're running out of time. But basically, I want to figure out how much this 60,000 investment will grow to. So this is cash money that we put in the bank a while ago. And so it actually gets its own interest, and it is going to end up being that. So let me get my calculator. So 60,000 times by 1 plus. So in case you're feeling confused, this is just a separate amount of money that he had saved, and it mentioned it in the question. And that money would have grown to 87,954.24. And I'm going to call that cash. So what do we have to work out? We know that a new car will cost us that much. How are we going to pay for this 198? Well, we have cash of 87,954.24. We've got the old car that we're trading in that gives us 95,951.26. How much money do we still need to pay for this new car? So I think it's just going to be 198,750.69 minus this thing down here. This is the amount of money that we have ready to roll. So give me the final answer. How much money do we still need to find? You're absolutely right, Morgan. You are absolutely on the money. So how much money does he still need? Or she still needs? He still needs. And then we're gonna, if you could just get the link ready for the quiz, because I think we're about to run out of time. 87. What are you guys getting? I'm getting 14,845.19. So he needs to go and find 14,000 Rand still if he wants to drive out of the dealership with a new car. All right, everyone, you have done so well.